Hey beautiful people, welcome back to my channel. My name is Busisiwe Dlamini Kharedi, the campus principal. I'm back again with another video. So in this video I want us to talk about the series dilutions. So what series dilutions are basically is when you do a multiple dilutions whereby you decrease the concentration of a solid and increase the dilution of the solid. So what do I mean by that? These are the dilutions usually that we will do in the laboratory, and especially we do them when we want to rule out human error, or when as well we find that after we've made dilutions but the concentration of the analyte is still very high. So here most of the time we would start by doing two dilutions, just for the fact that you're not doing one dilution, you're doing two. That is a series. So usually you can find that maybe you've just received a printout from the instrument and it shows a greater sign, and now you want to dilute sorry about that. You want to dilute that sample and you decide, or according to your SOP, you do probably a 1 in 3 and a 1 in 5 dilution. So these are the series of dilutions. And another thing that is important that you need to remember about them, it's that they are independent of one another. So what means is that if you've done something wrong on tube number 3, or on this tube whereby you did a 1 in 3, is not going to affect the result of what you've done on the tube where you've done a 1 in 5 dilution. So they are independent of one another. So in this case, yes, you will start with the two dilutions, and then after the concentration is still high, then you can go to 1 in 10, you can go to 1 in 20, depending on what the SOP of the laboratory says. And then after we have done these two dilutions, we would usually calculate the percentage difference between the two results that we would get from these tubes. The reason why we do that, like I said, we'll do it to try to minimize or to rule out human error, to make sure that whatever result that we are reporting, it will be a correct result, because a lot, like a pipetting technique, can also affect your dilution result. So that's why it's very important every time to calculate the percentage difference from the two results. So let's have an example. So let's say you just got a print out whereby a beta HCG result is high. It gives you a greater than, and you decide to do a 1 in 3 dilution. So how are you going to do a 1 in 3 dilution? We said it means a 1 in 3, it's 1 part of your serum, and then it's going to be 2 parts of your cell line, and it gives you a total of 3. So now you've done your, let's say you just said 100 microliters and 200 microliters, the volumes, and now you have your dilution. And then when you do a 1 in 5, it's going to be a 1 part of your serum, and then in 4 parts of cell line with a total volume of 5 parts. I hope it makes sense. And then after you have done your dilutions manually, what you do now, you're gonna take these samples, you're gonna run them into the instrument to run the beta HCG, because now you have diluted them, the concentration is a little bit lower. We are hoping that the instrument will be able to read, or whatever the concentration that is with it's in the tube, it's within the measuring range of this analyte called beta HCG in our case. So after you have done that, now you get a result. Let's say from your 1 in 3, you get a result of, let's say 100 microliters, for example. And then on your print out for your 1 in 5, let's say you get a result of 50, it's not microliter, it's millimoles liter, and here you get millimoles per liter, for example. So this is just an example. So in the previous video we did talk about a dilution factor. So this one is a 1 in 3, so it means the dilution factor is 3. So the result that you're gonna get between you have to multiply the result with the dilution factor. So in this case it's 100 multiplied by 3, which gives you 300 millimoles per liter. So what it means is that the ACG concentration in the patient's serum, this is what it is, right? And then from the 50, the one whereby you got 50 microliters, you're gonna multiply it by 5. So when you multiply 50 times 5, it's 250. So you get 250 millimoles per liter. And then after you've gotten results from your dilutions, because now you have 2 results, right? Now you need to calculate the percentage difference between these 2 results. And after you get the percentage difference, that it's gonna tell you whether you can accept these results or not, based on the total allowable error that shows a clinical significance. So how will you calculate the percentage difference between the 2 results? You will say first result minus second result, divide by first result, multiply by 100. Then you're gonna substitute. It's going to be 300 minus 250 over 300 multiplied by 100. Then you punch into your calculator, you're gonna get it's 50 over 300 multiplied by 100. So 300 into 50, it's 0, comma. Then when you add another 0, 300 into 500, it's 1 comma something. And then after that, you can multiply that by 100. And then you see that the difference is 10%. Then after you've gotten the difference of 10%, like I said, you will check the allowable error for this analyte specifically. So if this 10% it is within the allowable error, it means you can accept the result. But if it's not within, then you will need to do other dilutions. It might have been that probably when you were pipetting, you there was an error that happened there, or with the mix, it can be with the mixing and so on. And then after that, you will report the correct result. So basically these are the series of dilutions that we will do, and how you can put the dilution factor into our practice, and as well as multiplying the results with the dilution factor and getting the percentage difference between 2 results. And it's so important, I want to stress this, that it's important to get the percentage difference between the 2 results. And it's also important to do 2 dilutions, because if you're only going to do 1 dilution, if you only did, let's say, the 1 in 5 dilution, you get a result, you report it, how can you how sure are you that you did not do any error there in that tube? Because we are humans at the end of the day. If the pipette as well, probably it fell, it went out of calibration, it will also affect the volumes that you will use. So it is important that you don't do 1 dilution, but you do 2 dilution, basically to check yourself and rule out human error. And yes, this is it from me from this video. Thank you so much for joining me. I hope this makes sense. Make sure you interact with me in the comment section there down below if you have any questions, or if you need to supplement or you need to say anything, and I'll feel free to communicate with you. From me to you, up until the next video. Bye.